In this video, I want to have a look at finding the distance between 2 points on a number plane. So on your formula sheet, you've got this written. So it says the distance between 2 points can be found using the formula d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's finding the distance between 2 points when we have their coordinates as x1, y1 and x2, y2. So let's have a look at what that looks like in an example. Our first example asks us to find the distance AB for the points A, 2, 7 and B, minus 4, 10. So the first thing that we might want to do is label these as x1, y1 and x2, y2. Now it wouldn't matter if we'd labelled them the other way around. If we'd labelled these ones x1, y1 and these ones x2, y2, we'd still end up getting the same answer. But it is important that if this one is the first one that you use in your formula, if you use that as x2, then this one has to be y2. So you have to remain consistent with which points you're using. All right, so that distance, so AB, is going to be found going the square root of x2 minus x1. So we'll have minus 4 minus 2 squared plus y2 minus y1, so 10 minus 7 squared, which would give us the square root of minus 4 minus 2 would give us minus 6 squared, plus, and 10 minus 7 would give us 3 squared. So then minus 6 squared would give us 36, and 3 squared is 9. So we've got 36 plus 9, which would give us the square root of 45. Now that isn't going to give us a whole nice number, a whole integer as an answer, so we're going to leave it as a surd. But if we're going to leave an answer as a surd, we always want to simplify it if we can. So 45 could be broken down into 9 times 5. And we all know that the square root of 9 is 3, so we can write 3 root 5 units. So the distance between A and B is 3 root 5 units. We could put that in our calculator and approximate that answer as a decimal as well, but in mathematics we always like to leave things exact if we can. Our second example is more looking at applying the distance formula to prove something. So we're asked to show that the triangle with vertices 0, 6, 2, 0 and minus 2, 0 is an isosceles triangle. So an isosceles triangle has to have 2 sides that are equal in length. So to be able to approach this question, we're going to have to find the length of each side of that triangle and then show that 2 of them are equal. So we might as well start off with the side AB. So AB equal to, so we're finding that distance. So if we call this x2 and this x1, we'd go 2 minus 0 squared plus 0 minus 6 squared. Now that will give us 2 squared plus minus 6 squared, and that would be 4 plus 36, which would give us the square root of 40. So that's AB. Now we need to find our other sides, so how about we go AC next? And it doesn't really matter what order you do these in either, as long as you get them all, calculate all of the distances. So AC, let's go minus 2 minus 0 squared plus 0 minus 6 squared, which would give us the square root of minus 2 minus 0 would just be minus 2 squared plus minus 6 squared, which would give us the square root of 4 plus 36, which is the square root of 40. So this is looking really good so far because AB was the square root of 40 and AC is the square root of 40. So we've just shown that 2 sides of our triangle are equal. But let's just check our third one just in case, because if that third one is equal as well, then we would have an equilateral triangle, not an isosceles triangle. So let's try that one as well. So we're trying to find, we've already found AB. We found AB, AC, we need to find BC. So BC, we're going to have the square root of minus 2 minus 2 squared, and then plus 0 minus 0 squared. So minus 2 minus 2 is minus 4 squared plus 0 squared, which would give us the square root of 16, which is just 4. So that one's not the same, but these two are. So we can write, therefore, AB is equal to AC, therefore isosceles. And so that's two examples of finding the distance between 2 points on the number plane.